Welcome back to Refreshing Careers. Today we are going to do the part 5 of linear programming, which is subject under operations research. Today's question is, an organization produces X1 and X2 units of products M and N respectively. The profit per unit of M and N is rupees 50 and rupees 60 respectively. The production of 1 unit of M requires 4 units of raw material and 2 hours of labor, and of 1 unit of N requires 2 units of raw materials and 5 units of labor. The organization has 800 units of raw material and 1000 labor hours. To solve this problem using graphical method. Here we were supposed to solve the problem. Previously, in the previous questions, we used to formulate LPP. Here they are saying to solve. To solve the problem, first we have to formulate LPP. After formulation of that, we have to further do a few more things which I'll be letting you know. So let's focus on formulating LPP like how we used to do previously. Here they are saying that an organization produces product M and product N. Okay, we don't know how many units of M is produced, we don't know how many units of N is produced. So they themselves in the question are saying to assume that the number of units of M that is produced, they have told to assume it as X1, and the number of units of N that is produced, they have told us to assume it as X2. Okay, they themselves have told, so we know that, so we can assume this. So the assumption here is X1 is equal to total units of product M and X2 is equal to total units of product N. This they have themselves mentioned in the question. So that's why we can directly say that. So this is not assumption. This is directly given. This we won't say it as an assumption since it is directly given. Then they're saying that the profit per unit of M. For 1 unit of M, profit is rupees 50. For 1 unit of N, profit is rupees 60. And then they're saying that the production of 1 unit of M requires this much raw material, these many labor hours. The production of N requires this much raw material and this much labor hours. And then this is the constraint. The constraint is that you can maximum 800 units of raw material is there and maximum 1000 labor hours is available. This is the constraint, and are required to solve the problem. Okay, now this is a maximization problem. The objective here is to maximize. Now how do you know that you're supposed to maximize here? If it was cost, they would have mentioned that you're purchasing something, but here there's nowhere mentioned you're purchasing something and all. Here they have said that you're producing something. When you're producing something, when you're manufacturing something, this way when the question is framed, we have to understand by the formation of this question that they mean that this is a maximization case. So they are telling us to maximize profit. So our objective would be to maximize profit. So the objective is to maximize profit, and let us assume the total profits to be Y. We are assuming total profits to be Y. Total profits will be equal to profit from product M plus profit from product N. Profit from product M will be equal to total units of M into price per unit of M. Total units of M is X1. Price per unit of M is 50. Price per unit of M is 50. Then profit from M is nothing but total units of N, that is X2 total units of N, and price per unit of N is 60. 60 is mentioned in the question. This 60 is mentioned over here. Okay, so that's how we got this equation. This is the linear equation. This is the objective function. This is a linear equation for the objective function. So total profits is equal to X1, that is total units of product M, into price per unit for product M, that is 50, plus X2, that is total units of product N, into price per unit of product N, that is 60. That's how we got this equation. And X1 and X2, they are your decision variables. Now the constraints. The constraint here is for raw material and for labor hours. They said that maximum there's 800 units of raw material and 1000 labor hours. So let's write it down. 800 and 1000. For raw material, they said 800. For labor, it is 1000. Maximum this. So this is our constraint. The next thing which they're saying is the production of 1 unit of M. To produce 1 unit of M, you require 4 units of raw material. To produce 1 unit of N, you require 2 units of raw material. 4 units of raw material and 2 units of raw material. Okay. So equation would be 4x1 plus 2x2, and this is maximization case. So maximum it has to be 800. That is, it has to be either equal to 800 or it can be less than 800, but it should not cross 800. Either equal to 800 or less than 800, it should not cross 800. Maximum is 800. 4x1 plus 2x2. This is how we got it. Because they said that 4 units of raw material, that is C. To produce 1 unit of M, you require 4 units of raw material. To produce 1 unit of N, you require 2 units of raw material. That's how we got this equation. 4 units of raw material is required. 4 units of raw material is required to produce M. And how many M's do we have? We have x1 M plus 2 units of raw material is required to produce N. And how many N's we have? We have x2 N. And this is the total. This is the total raw material that is required by the organization. 4x1 plus 2x2 is the total raw material required by the organization, which can be equal to 800, or this total can be less than 800. It should not be more than 800, because they said that maximum available is 800. So 800 is the maximum raw material available. It has not crossed 800. That's how we got this equation. Now the next constraint. This is the constraint with regards to raw material. Next is the constraint with regards to the labor hours. That is 1000. They said maximum it has to be 1000. Okay, here what have they mentioned? To produce 1 unit of M, 2 hours of labor is needed. To produce 1 unit of N, 5 units of labor is needed. Okay, 2 units of raw material, 5 units of labor. So 2 hours and 5 hours. 2 hours and 5 hours. For M, 2 hours. For N, you need 5 hours. It has to be maximum equal to, so sorry, I wrote it wrong. Equal to 1000. Here what did I do? They have given that 2 hours is required to produce M. And how many M do we have? We have x1 units of M. Plus 5 hours is required to produce N. And how many N do we have? We have x2 units of N. So the total labor hours required by the organization is 2x1 plus 5x2, and the total labor hours should not exceed 1000, because 1000 is the maximum labor hours available. So this total, that is 2x1 plus 5x2, can be equal to 1000, or it has to be less than 1000. Either it can be equal to 1000, that is this one, or it can be less than 1000. That's how I got this equation. This is the constraint. This is a constraint with regard to labor. Okay, so these are your constraints. And the next is non-negativity condition. This is the simplest. Here x1 greater than equal to 0, x2 is greater than or equal to 0. Your decision variables x1 and x2, can be positive, can be 0, but cannot be negative. Okay, x1 and x2 can be greater than 0, equal to 0, but will not be negative. Okay, and what is x1, x2? x1, x2 is the units of product time and units of product time. Whatever you are producing, it cannot be negative. Either there is zero production there is some production. There won't be some -2 units of M produced. There's nothing like negative production. So there's either no production or there is some production. Some production will be positive, right? It can't be negative. That's why this condition comes. Now let us write down what all we solved. Our Z, our objective function, like what you found in the beginning, will be maximum Z is equal to y, right? We took it as y. So maximum y is equal to x1 into 50 plus x2 into 60. x1 into 50 plus x2 into 60. x1 into 50 plus x2 into 60. This is your objective function. The next thing is your constraints. All this subject to two constraints. The first one is with regard to raw materials. That is 4x1 plus 2x2. 4x1 plus 2x2 less than or equal to 100. 4x1 plus 2x2 less than or equal to 800. The other one is 2x1 plus 5x2 less than or equal to 1000. 2x1 plus 5x2 less than or equal to 1000. And a non-negativity condition is your non-negativity condition is x1 greater than or equal to 0, x2 greater than or equal to 0. Okay, I've summarized everything. Now after this we need to find the solution. Okay, to find the solution we'll be using graph. Before we use the graphs, we need to find the values. Okay, we need to find certain values. We need to find the value of x1, x2, all these things. So first we need to take this. Okay, the first thing which you have to do is you have to take this into consideration. Subject to that your constraints have to be taken. With the help of your constraints, that is these two equations, you should be able to find the value of x1 and x2. I'll be telling you how. First I have to convert it into an equation. So let's take the first equation first. Okay, we'll take the first equation and solve it, and then we'll take the second equation and solve it. So I'll be taking the first equation. Please not get confused how it came. Okay, 4x1 plus 2x2. 4x1 plus 2x2. This is a constraint. 4x1 plus 2x2 x2 is equal to 800. See here I'll be writing it as equal to, but in reality what is it? But actually it was less than or equal to. I'll be writing it as equal to because I'm making this as an equation. Since I'm solving it in graph, I need a linear equation. That's why I'll be putting it as equal to. Okay, now what we need to do next is next thing that you need to do is let your x1 be equal to 0. Let your x1 be equal to 0. Then what will happen? If x1 is 0, 4 into 0 is 0 plus 2x2 is equal to 800. So 2x2 will be equal to 800. So your x2 will be equal to 400. x2 will be equal to 400. Okay, x2 will be equal to 400. And your x1 is what? x1 is 0. Okay, this is one case. Now next. Now in the second case, you assume let your x2 be equal to 0. Now if x2 is equal to 0, then 2 into 0 is 0. So this one is not there. Then it will come 4x1 is equal to 800. 4x1 is equal to 800. 4x1 is equal to 800. So your x1 will be equal to 200 and x2, like we assumed, will be 0. Okay, now this will help us in the graph. Now another thing that you need to do is same way for the next equation we're supposed to do, that is this 2x1 plus 5x2 is equal to 1000. We'll take it as equal to because we were converting it to a linear equation. That's why I'll be taking it as equal to 2x1 plus 5x2 is equal to 1000. 2x1 plus 5x2. 2x1 plus 5x2 is equal to 1000. I took it as equal to. So this is your second constraint. We are taking only the constraints. Okay. And now same thing what I did previously. Let x1 be equal to 0. If your x1 is equal to 0, 2 into 0 is 0. So this one goes, this term goes, and you have this left. So 5x2 is equal to 1000. 5x2 is equal to 1000. So your x2 will be equal to 200 and x1 is 0. x1 is equal to 0. Same thing you do. Let assume x2 to be 0. Okay, let x2 be 0. Here let x1 be 0. Let x2 be 0. If x2 is 0, then find to 0 0. So what will be left? 2x1 is equal to 1000. 2x1 is equal to 1000. So x1 will be equal to 500 and your x2 here is 0. Okay, so that is how you got all these values. Okay, now let's assume in the graph, okay, your x1 is x and your x2 is y. Okay, let this x1 be x and x2 be taken as y. I'll write it somewhere here. This is 0. Your x this is your x1 and this is your x2. Okay, x2 is equal to y. Okay, I'm considering x2 to be y and I'm considering x1 to be x, so that I'll be able to plot. And now we know the values. Okay, these are the values. Let me just put it down. Here your x is 0 and your y is 400. So just write it down. X is 0, y is 400. Here x is 200 and your y is 0. Go to the next. Here your x is 0 and your y is 200. Here your x is 500 and your y is 0. How did I do this is, I've taken it this way. These are the points. 0, 200 is a point in the graph. 500, 0 is a point on the graph. I'll be marking it in the graph. And how did I get the point? The first numerical that I have written will be what will come in the x. What will come in the x, and the second quadrant and the second numericals I written will come over here. The y. Okay, that is 0, 200. This is a point. Okay, this is a point. This is another point. We will be joining these 2 points to get a line. Similarly, we will be joining these 2 points to get another line. The points, see, after joining this point and this point, the line which we will get will be representing this constraint. And after joining this point and this point, the line which we get will represent this constraint. Okay, to represent this constraint we need some points, right? So these are the 2 points that we found out by assuming first that x1 is 0 and then by assuming x2 is 0. Okay, so these 4 points we will be marking over there and we will be forming a linear equation on the graph. We will be forming a line on the graph. So here all the values are like 200, 400, 200, 500. Okay, these are the values needed. So Now I'll leave some here, 200. Okay, I've made this graph little roughly. We have to actually, if you plot this in a graph sheet, you'll get it correctly. Okay, now the points. Now we'll be marking these 2 points. The first point is 0, 400. The first point will always represent x, the second will represent y. This will represent x, this will represent y. Here we have taken x2 as y. Okay, so x2 is nothing but y. Okay, so 0, 400. 0, 400 is, this is 0. 0 is over here. Okay, 400 is over here. So this is 0, 400. That's on x-axis you have to search for 0. That is here. On y-axis you have to search for 400. That's here. So this is your first point. So mark it. I marked it in another color and mark it with green. This is 400. Okay, I just crossed it. Yeah, this I just put a dot. Okay, wherever I put green dot, understand that this is the first constraint. Okay, this is the first dot. Now the next point that we found is 200, 0. 200, 0. 200 on the x-axis. This is 200 on the x-axis and 0 on the y-axis. 0 on the y-axis. The y-axis 0 is here. So this is your point. So mark this. Okay, so I marked this and this. So we marked this point and this point. Now we need to join this. Let's join this. Okay. Okay, so I joined the points. So this is your first constraint. Okay, the green color is the first constraint. Now the second constraint, 0, 200. Okay, so mark 0, 200. Where is 0? On the x-axis we need 0, that is here. 200, that is over here. On y-axis we need 200. So 0, 200 is the point over here. Let's take another color. I'll take purple. Okay, so here I'm marking this point. Right, now after this, for the second constraint, the second point is 500, 0. 500, 0. That will be in between this. So on x-axis we need 500. That would be somewhere between 400 and 600. That is over here. 500, 0. 0 on y-axis. So this is the point that you have to mark. So let's mark it. This is the point that you marked. It's not perfect term. Okay, please understand. This is the point. Okay, in middle it will come. And then we need to join it. And then, okay, I've joined this. So your green line is the first constraint and this is your second constraint. This is your first constraint and this is your second constraint. To understand better, now there are many points, right? Just name the points. The point over here, let us name it as A. Okay, I'm just naming these points so that we can refer to it easily. A, let this point be B, and this point let it be C. Let this point be D. Let this is 0. Let this point be E. Okay, what I've done is I just named all these points. Okay, so this point that is 0, 400 is A. This point is B. This point that is 500, 0 is C. This point that is 200, 0 is D. This point that is E. That is this point 0, 200. This is the E point. I just named this point. Now I have named this point. Now we have to find the feasible region. We have to find the feasible region. Let's mark the green area. Why are we marking this inward? Okay, there is inward marking because there was less than symbol, right? If you remember the equation, it was less than or equal to. That is the symbol. Whenever there is less than or equal to, we will be shading inwards, that is towards the origin. Okay, let me just show you one. This is your first constraint, and this constraint is this green marking. Okay, AD is your first constraint. AD is your first constraint, and this AD was represented, it was like this, right? This was the equation, it was less than or equal to. Whenever you have this less than or equal to symbol, and whenever you have to represent such a constraint on the graph, since you have less than, that's why you will shade inwards. You're going to shade it inwards. Inwards means AD is your line, right? When you're shading inwards means you're shading it towards the origin. Okay, when you're shading it towards the origin. If it was maximum, okay, let's say if this equation was greater than equal to 800. If it was greater than equal to 800, then what you would have done? Then you would have shaded outwards. That is, if it was like that, okay, I'm just saying, if then your shading would have been, this area would have been the area that you would have shaded. You have shaded outwards. Okay, but since it is minimum sign, since it is the sign of minimum, that's why you're shading it in this way. Now the next thing is, this is your next equation. This also is the case of minimum, right? Because it is less than equal to, again less than symbol came. That is, you have to shade it inwards. Okay, you have to shade it inwards. So second constraint is represented by EC. EC is your second constraint, and you have to shade it inwards. So let us shade it inwards now. We have to shade it inwards, and then we have to figure out the common area. That is understood, right? What the common area is. Okay. So now after shading, we can understand the common area is EBDO. Okay, your E, your B, your D, O. This is your common area. Okay, EBDO. Now we should find the point B. Okay, if you do it correctly, precisely in a proper graph sheet, you will be getting the correct answer. Now let me tell you what will come over here. Okay, after plotting in a graph sheet, this is what I've got. B is equal to 125, 150. Over here it is not that precise, but you can make out in this way. This point is 0, this point is 200. So this is 100. So it is some point in between 100 and 200, somewhere little before half of 100. That is, if this is 100, okay, this line is 100, this line is 200, in between will be 150, right? In between is 150, but this point is coming little before 150, so it is 125. If you plot it in a proper graph, you'll get this. So you can check out in a proper graph. You can do this. You can make it in a graph sheet, and then you'll get 125. Similarly, for this, okay, this point is coming over here, right? It is 150. Okay, if you plot it properly in a graph, you'll get y as 150, you'll get x as 125. Your x will be 125, your y will be 150, and you are plotting it in a graph sheet, in a correct graph sheet. So now this is your feasible area. What is your feasible region? Your feasible region is EBDO. You have to make note of this. Okay, feasible region. Okay, so the feasible area is EBDO, as you saw in the graph. EBDO is the feasible area. E, that is this, BDO, and all these points, I've just written it down over here. EBDO. These are the points with respect to E is, this is the point E, this is the point B, this is the point D, and this is the point O. Now, this question, what is the objective? Now we have to look at the objective function. After solving the graph, after that stage, after finding the feasible area, that is when you have to look at the objective function. So objective function is the maximum function. You have to maximize profits. Okay, since you have to maximize profit, you would want the highest digit over here. So let me just write down the equation over there. Y is equal to x1 into 50 plus x2 into 60. Y is equal to x1 into 50 plus 60. Y is equal to y is equal to x1 into 50 plus x2 into 60. What is my mission? Y is your total profit. I want my profit to be as maximum as possible. I want my profit to be as maximum as possible, right? If we all would want like that, right? We want our profits to be as maximum as possible. If I wrote it wrong, it is x2 into 60. Okay, this is x2 into 60. This is x1 into 50 plus x2 into 60. We want our profits to be as much as possible. So to increase this, okay, x1 and x2 has to be highest number. Like if I put this, okay, if I replace x1 by 0, x2 by 0, so your profit will be 0, right? This represents x1 and the second numerical represents your x2. So if I will be putting it in the equation 0 into 50 plus 0 into 60, it will be 0. So it's 0 profit. Similarly, if you put it in this way, that is x1 you put it as 0 and y that is x2, y or x2 you put it as 200, then it will be 200 into 60 will be a y. Similarly, in case of D, if you put your x1 as 200 and your y or x2 as 0, then this will be gone, right? So what will be left out is this 200 into 50. So this is the only point which will give you the maximum profit. If you are taking the point B, comparatively compared to E, D and O, B is the best point. If you take x1 as 125 and if you take x2 as 150, then your profits would be the maximum when compared to E, D and O. That's why you will have to choose this. So your answer would be x1 will be equal to 125 and your x2 will be equal to 150. So now we need to solve this. Y is equal to x1 is 125. This is the optimal solution because that is what, because this is the only point that will give you the maximum profit. You can solve each one and check. Okay, if you solve for this point, your answer will be 0. Your y will be equal to 0. If you solve this, if you replace, you solve this, your answer will be equal to, profits will be equal to 200 into 50, that is 1000. If you do this, your answer will be equal to 200 into 60, that will be 1200. And this will be obviously more. Okay, by just looking at it, we can find out that this point will give you the maximum number or the maximum amount, and what we need is the maximum itself, because we need the maximum profit as much as possible, right? So your x1 will be 125 into 50 plus your x2 is 150 into 60. So your y will be equal to, we will just solve this. 6250, can use calculator for this. And the second one is 150 into 60, that is 9000. Your total y will be equal to 9000 plus 6250, which is equal to 15,250. This will be your answer, 15,250. This is your maximum profit. Okay, this is the solution for this. And we have solved this entire question using graphical methods. You can solve LTP, you can solve this linear programming problems with various methods. I'll be teaching you the other methods also, but this is one of the methods. This is one of the simplest methods, and there's one limitation of this method that we should be knowing. You can solve this method only if there are two decision variables. That is, in this case, as we can see, there's only x1 and x2. That's why you can use this method. If it was x1, x2, x3, x4, if there are like more than two decision variables, okay, which we need to find out. If there are like two variables that we need to figure out, then we can use graphical method. But if it is more than two, we cannot use graphical method. Graphical method can be used only when it is more than only when it is not more than 2, that is, it has to be 2. Okay, only when it is 2 you can use. Above 2 you can't use. Okay, you can use this only when x1 and x2 is there. Okay. Other than this, you'll be solving few more problems related to graphical method. Please do like and subscribe the video. Thank you so much.